Let's find the point of intersection between two lines here. So we have two lines whose parameterizations r of t is I hat plus t times negative 3 I hat plus j hat. S of t is j plus k plus t times 2 I hat plus k hat. I'm going to do a first pass at solving this problem here. There's going to be a little mistake in it, so we'll patch this up later. So our initial wrong approach. So the thing is that we're trying to find a point that lies on both of these. We want to think about setting up systems of equation. And this part is good. We want to set up some equations here. And so we want to think about setting up an equation for each of component here, the I hat, the j hat, the k hat components. So for and we want to write down what's going on with I hat, with j hat, with k hat for each of our two parameterizations here, r of t and s of t. So for r of t, the I hat component is 1 minus 3t. The j hat component is going to be just t. And there's no k hat component. Really what I should say is the k hat component here is 0. As for s of t, the I hat component is going to be 2t. The j hat component here is 1. And the k hat component is going to be 1 plus t. And so we want to solve these three equations here. So it looks like we're going to try to find a value of t that satisfies each one of these three equations. And if you try to solve the system of equations here, you'll find there is no value of t that satisfies all three of these equations. But as it turns out, this actually, there is an intersection point of these two lines here. But this setup, we have to tweak it just a little bit before we can use it. Let me explain what's going on here. So imagine I have these two markers are serving as my lines here. So it's clear, that like they aren't exactly in the same place, but the point here, let's say that like right here is where they're intersecting. So at this point here on the black pen, this might be t is equal to 3. But at this point here on the purple pen, that might correspond to t is equal to 2. So the thing is that, these lines intersect at this point, but it's different t values for r of t and s of t. So how do we patch that up? We need to adjust the t values here to make them different. This setup is assuming that the t for r of t and the t for s of t are the same exact t when that's not the case. So there's a couple ways we could patch this up. One is that we could change one of the t's to be some other letter, like a w or r or some, I guess not r, because we already used that w, a v, some other letter here. Another way to do it, which the way I'm just going to do it is I'm going to put subscripts here. So r of t1 and s of t2. So t1 and t2, these are different variables here. Okay, so now let's go ahead and crunch out this system of equations. So t1 is equal to 1. I'm just going to recopy that. That tells us t1 is equal to 1. 0 is equal to 1 plus t2. That shows us t2 is equal to negative 1. And we have to make sure all three equations here are satisfied. So let's take these values of t1 and t2, plug them up here. What do we end up with? 1 minus 3 times t1 is 1 is equal to 2 times negative 1. And sure enough, negative 2 is equal to negative 2. This checks out. So hooray, we have found the two values of t1 and t2 that give us the point of intersection. But we're not done yet. We need to say what is the point of intersection. And so that's going to be r of t1 is going to be 1, and that's going to be I hat plus 1 times minus 3 I hat plus j hat. And that simplifies down to negative 2 I hat plus j hat. And s of negative 1 is going to be j hat plus k hat minus 2 I hat plus k hat. And again, this crunches out to negative 2 I hat plus j hat. So these are equal. So what is our point of intersection? Negative 2 I hat plus j hat. Okay, so hopefully this was an instructive example of how to find points of intersection of two lines. You need to remember this trick. This is a very useful trick. Let me do one more example in this vein here. So once again, I want to find the point intersection of these two lines here. This looks very, very similar. I'm calling my lines R1 of t and R2 of t instead of RS. I'm writing them with this notation instead of the I hat, j hat, k hat notation. But everything should go through in the everything should go through in the correct way. And I guess on the previous slide, at some point I really should have crossed this out and said this is the right way as soon as we say 1s and 2 subscripts there. Okay, so what is going to happen here? So let's set up our system of equations just as we did before. And so I'll have R1 of t, and I will have R2. Let me use a different letter here. Let me use R2 of s here. So t and s are going to be my variables. R1 of t is going to be 2 minus 4t, and that will be the I hat component. The j hat component is just 1. The k hat component is 1 plus t. Now I have R2 of s here, so everywhere I see a t, I'm going to replace it with an s. Minus 4 plus 2s. And then 1 plus 1s. And 5 minus 2s. Okay, so as before, let's go ahead and solve the system of equations here. So this one says that 1 is equal to 1 plus 1 times s. Subtracting 1 from both sides here gives us that s has to equal 0. We already have right away that s has to equal 0. So let's plop that in to this equation here. If s is equal to 0, we've got 1 plus t is equal to 5 minus 2 times 0. And this gives us that t has to equal 4. So hooray, we found t is 4, s is 0. Let's check that by plugging this into our I hat equation. So we're going to get here 2 minus 4 times 4 is equal to negative 4 plus 2 times 0. And this crunches out as 2 minus 16 is negative 14. And minus 4 plus 0 is negative 4. And wait a second, these aren't equal here. So what went wrong here? So first, there's nothing wrong with our calculations. We didn't botch up anything in here. We wrote down the correct equations. S had to be 0 here, t had to be 4 here. But when we plug in to this I hat equation, it's not checking out. We have what we call an inconsistent system of equations. And why is this? This is because these two lines actually don't intersect. If I have this purple marker is one line and this black marker is a second line here, these lines just don't intersect. It's kind of special for two lines to intersect. In general, we should not expect two lines in three-dimensional space to necessarily have to intersect. Let me point out something important here. This is very different than working in two-dimensional space when, in general, a pair of lines intersect once, unless they're the same unless they're the same line or unless they're parallel. So if they're parallel, they don't intersect. But in three-dimensional space, I can have these lines. These aren't parallel in any sense of the word. They're not, going in the same direction, but they don't intersect. So important thing to know here, lines may not intersect.